In this video, we'll be going over the recursive approach of maximal square. So given an m times n binary matrix filled with zeros and ones, find its largest square containing only ones and return its area. So in our first example, we're given this matrix, and then the maximum, the largest square we can find has an area of 4. So which is these two, so we return 4. Let's go over the thought process. So for each of the cells at RC with a value of 1 can be represented as the top left corner of a square. Now how can we find the area of the current square? We will first need to find the length of the squares to the right, bottom, and bottom right. So the square at the right has a top left corner at r and c plus 1, and then to the bottom, the square to the bottom has its top left corner at r plus 1 and c, and the square at the bottom right has a top left corner at r plus 1, c plus 1. Now let's indicate the three lengths as a, b, and c. Then the length of the current square at the top left corner at RC will be equal to the minimum value between ABC incremented by 1. Now to find the area of the current square will be length square. So we will want to pick the longest length out of all of the squares. Then to find the area, or the largest area, we can perform length square. Let's go over a simple example. So if we're currently at the top left corner here, we want to find the length of the square here. We first need to find the length of the square to the right at this cell, to the bottom at this cell, and to the bottom right at this cell. So the longest length of the square here is equal to 1, and then the longest length here is equal to 1, and the longest length of the square here is equal to 1. And then to find the length of this square here, we need to pick the minimum value between these three. So we each have a length of 1, and then we increment it by 1, so we get 2. So this square here has a length of 2. And then to find the area, we just do 2 times 2, and we get 4. Now let's go over the pseudocode. So we're going to create a variable, max length, to keep track of the square with the maximum length. Now when it iterates through the rows and columns of the input matrix, which we denote it as RC. Now we're going to implement our recursive approach to find the length of the square with the top left corner at RC. Now what parameters do we need? We'll need the current row, the current column, and also the input matrix, now what's the base case? If RC is out of bound, or matrix RC does not contain a 1, then the length of the current square will be equal to 0, so we can just return 0. Then each of the recursive call, then we will first want to recursively find the length A of the square to the right, which is, so R stayed the same, so C gets to increment it by 1. And then we'll recursively find the length B of the square to the bottom, which is row incremented by 1. And then we're going to recursively find the length C of the square to the bottom right. So it's r plus 1 and c plus 1. Then we want to return the minimum value between ABC incremented by 1 to find the length of the current square of the top left corner at RC. Now, after we find the length, we're going to update max length if the length is greater. If the length of the current square is greater, then we want to return max length square, or max length times max length. This is to find the area of the largest square. Now let's go over the time and space complexity. For the time complexity is O of n, or O of m times n, times 3 to the m plus n, where mn are the length, are the number of rows and columns. So for first one is m times n, we just iterate through all of the rows and columns. Then we implemented our recursive approach, which is this one, to find the length. And in this case, we get, so each recursive call has up to 3 choices and a depth of m plus n. And then our space complexity is m plus n, which is our recursive call stack memory. Now let's go over the code. So we'll first create a variable, max length, to keep track of the maximum length of all the squares. Then we'll iterate through all the rows and columns. Then we iterate through the columns. Then we want to find the length of the current square of the top left corner at RC. And then we can return the max length square, so it's max length times max length. And then we're going to create our recursive helper method to find the maximum square of the top left corner at RC. Now we'll first go over our base case to check if we are out of bound or not. So if R is greater than or equal to max length, or C is greater than or equal to R dot length, or the current cell at RC does not contain a 1, we can just return 0. Now we want to return the minimum value between the squares to the right, to the bottom, and to the bottom right, and then we can increment it by 1. So let's first find the length going to the right. So C plus 1 matrix, and then we want to find the length of the squares to the bottom. So it's R plus 1. And then lastly to the bottom right, which is R plus 1, C plus 1. And then we can increment it by 1. Okay, we are getting our TOE error. So this recursive approach is not efficient enough due to overlapping recursive calls. Then we can avoid overlapping recursive calls using memorization. In the next video, we'll be going over the memorization approach of maximal squares. Let me know if you have any questions in the comment section below.